Thank you. Today I'm going to present an initiative where I am involved as an organizer, and it's about the purpose is to try to address the issue of misinformation, especially in combination with search engines. So here there is an example. Again, it's about COVID-19, and these are the results you may find when you type the query, can smoking prevent COVID-19 on Google or any other search engine. So common sense will suggest us that it's not a good idea to start smoking to prevent COVID-19. But what happens, especially with more complex queries, I don't know, I can think about vaccines and all the public debates we have now with COVID-19 vaccines. Some information can be very technical, and it can be hard for the user to distinguish between what is correct and incorrect. So all these results that we see here, they can be considered correct by a user. They are all relevant, and they are somehow useful because they are about the topic that the user is looking for. And they might affect the final decision of the user, and they can have very large consequences on the user final decision, as also Isabel was pointing out about people drinking bleach against COVID-19, for example. So it's very important, the role of search engines and the information they show in the result page, because we saw that can actually affect user decisions. So today I'm going to present the TREC, Health Misinformation TREC. As I said before, this is an initiative, and I am a co-organizer of this TREC. Then I will present some of the approaches that were submitted to the TREC to identify misinformation in search engines, and I will show some results and a final wrap-up. So what is the TREC Health Misinformation TREC? So this it's an initiative proposed in the context of TREC. TREC stands for Text Retrieval Conference. It's sponsored by NIST, based in the US, and started in 1992. And every year there are different shared challenges. So you can think about this TREC as a sort of challenge, and researchers and people, practitioners in the field, they can participate, they can submit their systems, and then we evaluate and compare systems. So the specific case of the Health Misinformation TREC is co-organized by me and Mark Smucker and Charlie Clark from Waterloo University. The short-term goal is to improve the quality of the retrieval for search engines, specifically for health search. And also the purpose is to promote credible and correct information. The long-term goal is to try to predict what will be the user decision based on the results that the user gets from the search engine, and try to improve the results of the search engine to kind of help the user taking the correct decision. So in the TREC this year, what we did as organizers, we provided the participants with a corpus, so a set of documents that I can use to search. And this year we chose the Common Crawl News Crawl. So it's a large set of news web pages that are actually crawled from the web. We took a sample of 4 months, and it was about 1.7 terabyte of data. Then, as organizers of the TREC, we defined some topics. What are topics? So topics are a representation of the user query. Here on the right, you have an example of a topic. So you can see this is the title, vitamin D COVID-19. These are the keywords that a user might input in a search engine. And then there is a description that is, can vitamin D cure COVID-19? So this is the kind of questions that the user has. And then we also looked for the answer. In this case is no, and we have the evidence here. And then there is a narrative that's something that was used for the evaluation. It's kind of to describe better what is the user information need. So then there were two different tasks in this track. So one was the total recall task. So the participants were challenged to find all the documents that convey misinformation. So for this case that we have here on the right, they had to find all the documents that were actually saying that vitamin D can cure COVID-19. And the purpose is to identify them so that we can either filter them down or put them lower in the list. And the second task, we will focus on the second task in this talk, is the adopt task, and it's a ranking task. So it's very typical of the search engine case. Given this query, you need to rank all the documents that are relevant for this query. And in this specific case, as I said, we want to promote documents that are also correct and credible. So participants had to produce this ranking of documents where at the top of the ranking, there were the best documents in terms of relevance, credibility, and correctness. So this was an overall idea of the track, and now I will present you two different approaches from two teams that participated in this track. But the first thing I will present is BM25. So if you work in IR, you know very well what BM25 is. BM stands for best match. This is a really simple baseline, and it's the whenever you have a ranking problem and you want to generate a ranking of documents, the first thing you try is BM25. It's a very simple baseline. There is no machine learning involved. It's just about the frequency of terms. So if we ever look at this equation at a high level, so this will return the score of a document given the query. And then the higher the score, the more relevant is that document for the query. So the higher we should rank this document in the ranking. And you can see this is the FTD is the frequency of the term D. And this term appears in the query queue in the topic. So this is the frequency of the term in the document. And this model actually just used the frequency of the term and this weighting schema here, which is also based on frequency of terms. So it's very simple. And this is the basic step we usually do in IR. And you will see it's both used by both teams and approaches I will present. So the first approach was from KU. Both me and Isabel were involved in this team, and we had the help from Lucas and Dustin, two PhD students at DICU. So what we did, as I said, we start with BM25, and we get this first ranking here. This is just ranked, documents are just ranked by relevance. And then what we did for these documents ranked with BM25, we tried to estimate the credibility and the misinformation score. Once we had an estimate of credibility and misinformation, then we merged these scores and we produced our final ranking. So how did we do this in details? For credibility, so to estimate the credibility of one web page, basically we use two different types of features to represent the documents. Some were based on the content. So for example, the readability of the text, and some features were based on the number of definition of CSS, for example. And then we had some popularity features, as for example, page rank, or if the domain contains like the .gov or .edu keywords. Then we trained very classical classifiers as SVM or logistic regression with the Microsoft credibility dataset, and we predict credibility. For misinformation, we treat the problem as a stance detection problem. So this was included in the fact-checking pipeline that Isabel presented. And basically what we had from these fact-checking problem methods is that we have a probability that the document agrees with the topic. So for example, in the previous case that vitamin D cannot cure COVID-19, and the probability that it disagree. And then we basically consider this difference. So the higher the score, the more the document agrees with our topic. And then we used Roberta to represent documents and the fake news challenge dataset for training. As I said, we merged all this core after standardization, and and then we used some weighted averages or some rank fusion approaches from IR. The second approach I wanted to present you is from Waterloo University. Again, you can see here on the left, they used BM25 as a starting point. They also did some expansion, but basically the main, the first step is really the simple BM25. And then they did some re-ranking. So the first re-ranking step is based on T5, and it's a point-wise re-ranking. It means that we take the query, the document, and we compare their similarity. So more similar is the query, more similar are the query and the document, the more relevant is the document, so the higher we should rank it. And the second re-ranking step, it's again using T5, and it's a pairwise ranking. So the main difference is that now we take one query and a pair of document, and we return a sort of pairwise preference. So whether we prefer D1 or DJ. And we use this preference again to rank documents. So the reason why we don't start directly with these T5 approaches to rank documents is that basically they are quite expensive in terms of computational power. So we cannot really afford to do this. So that's why we use BM25 as a starting point. And then the last step, they use again this T5 model to predict how much the document basically supports or rejects the topic. So what is T5? Very quickly, it stands for text-to-text transfer transformer. So 5 Ts. It's a deep neural network model based on transformer. It's pre-trained again on the common crawl dataset, but it's a much larger and clean version that they use. And it was proposed by Google. Basically, it's a model that can be trained for different types of tasks, all of them dealing with text. So let's go and have a look at the experiments. As also Isabel pointed out, evaluation is very important. And one of the problems we had as organizers when we ran this task was how should we evaluate the results of these systems. So the participants, they ran their system and they return us a list of documents for each query, and then we actually need to associate a score to each list, to each system. So what we did for this specific case, each document was labeled with 3 aspects: useful, correctness, and credibility. And correctness basically was looking at whether the document was answered correctly to the question in the topic. And then we divided these documents in 2 sets. Let's say documents that are helpful. So they are useful, correct, and credible. These are the best documents we can have. And documents that are harmful, where useful, incorrect, and credible documents, they're the kind of worst documents we can have, because those are the documents that are really misinformation. Given these 2 sets of documents and the preference among them, we used a compatibility measure. So here you can see a plot where we have on the x-axis here the score of compatibility for helpful results and harmful results here. So in principle, we want this harmful score to be low and the helpful score to be high. And these are all the systems that were submitted to the TREC by different teams. So you can see here in blue the BM25, so our baselines. You can see that, for example, these use just the title, and this also uses the description. And if we use the description, so the small question, not just the keywords, we can see that we increase the harmful results. And basically what happens is that when we use the description, we had some keywords as cure or prevent, and these actually seems to attract misinformation. So now if we have a look at this plot here, if we slice this plot vertically, the idea is that all these systems, somehow they have more or less a good score for helpful results, and the better systems are those that are kind of low here, and they have a low harmful score. So these ad hoc results are how our KU runs. So we can see that we actually were quite good in finding helpful results, but we need to improve our system to reduce harmful documents. And these are the results, these H2 from the Waterloo team, so that they could actually, maybe this green one is the best system, which has a good score for helpful documents results, and can keep the harmful documents at a low score. So just to wrap up, what we see is that there are very promising solutions to solve this problem based on neural network models and fact-checking models to detect misinformation. The TREC we run next year as well. We will have a new task next year, and it's about predicting the user decision based on the results that we show. So again, we will have some future work next year dealing with evaluation and how to account for the user decision when we evaluate these systems. So thank you.